So today we are gonna do a theoretical question, which is dimensionally correct equation necessarily to be a correct physical relation? If you watch my other videos, you might already know the answer about this. So what about dimensionally wrong equation? So if you watched my previous videos, you might have an answer to what the answer is. So let's write the answer. So the answer is no. Dimensionally correct equation necessarily does not mean it is correct physically, because the relation is not applicable for actual calculations. It works, but it does not work in reality. It works dimensionally, but it does not work in reality. So let's take a most why take equations to make it complex. Let's just take a simple thing. So for example, frequency and angular velocity have same dimension, which is t minus 1, but their units are different. So the unit of frequency is hertz, which is per second, and the units of angular velocity is radian per second. Since radian is a supplementary quantity and does not have a dimension, it looks like both angular frequency and angular velocity and frequency have the same dimension, but they don't. So now we have this. So hence they are dimensionally correct, but physically not a correct relation. Since this was applicable for even the simplest terms, it will also be applicable for equations. So if we're talking about equations may be dimensionally correct, but it may not be physically correct. So let's put a big no. So that's a no. So now let's continue with the second part, which is what about dimensionally wrong equation. So for the second part we can write, and dimensionally wrong equation is always a wrong physical relation. And if you watch my previous videos, you know that this is a fact, because since if it's wrong dimensionally, one of the units is not gonna match anyway, because if there is a dimension, there is always a unit. But if there is a unit, there may be or there may not be a dimension. But if there is a dimension, there is always a unit. So if the dimension don't match, the units don't match, which means it's a big trouble. The units don't match in a sense that their dimensions don't match. So it's like going back and forth. So this was it for today's video. In the next video, we are going to do another question.